Okay, the last section of chapter 3 is the geometric sequence. The geometric sequence, just like the arithmetic sequence, has its own formula. T sub n, or the nth term, is equal to the first term times the ratio of n minus 1. Again, n is the whatever term it is you're looking for. Now, if you're having problems finding a ratio or it's not obvious to you, you can find the ratio by dividing the second term by the first term, or any sequential. The 10th term divided by the 9th term, the 21st term divided by the 20th. It doesn't matter as long as you have two that are sequential, and the second one goes on top, the first one goes on the bottom. Find that ratio, and that's what's going to go in the R location. We have 6 examples again today. The first example is we want to find the nth term, or the general formula of a given sequence, 81, 54, 36, 24, ... So we want to find what its formula would be. What is the nth term? If I know the first term, the ratio, and then n minus 1. Now the ratio, if you can't look at it and obviously figure it out, you take any two sequential terms, and it doesn't matter. I'm just going to pick the last two. Reduce that, and you see 12 goes into them, and you're done. You cannot combine 81 and 2/3. This is an exponent, and this is a number. If you combine those, it tells me you do not know your order of operations, and by now you should definitely know your order of operations. This is your first term, this is your ratio, and then n minus 1. Leave it alone. You're done. On the second thing they're going to be asked to do is to find a specific term. So for example, the 6th term. We're going to use this same sequence. Now, of course, you could just keep going, and find the 6th one. It's not too far out. But if I ask for the 16th or the 60th, you're really not going to want to do that. So we're going to use the formula. If I want the 6th term, it's going to be 81, and then 2/3, and then 6 minus 1, because it's the term I want, is the n. So that's 81, and then 2/3 times 5, or to the 5th power. So that's 32 over 243. That reduces, so we get 32/3. The 6th term in the sequence would be the number 32/3. All right, example 3 and example 4 are much like yesterday's, meaning I'm going to ask you to find a term, give you 2 other terms, and you're going to have to write 2 equations in order to solve them out. So the first thing is given the information. So I'm going to ask you to find T7 if you know T2 is 6 and T5 is 750. So we're going to set up our 2 equations the same way we did with arithmetic, just we're going to use the geometric sequence equation. So T2 is the 6th term, or is the value of 6. We don't know T1 and we don't know ratio, just like we didn't know T1 in difference for an arithmetic. We don't know T1 in ratio. But we do know the n minus 1. So that becomes 6 is T1 and R, because 2 minus 1 is R. Then the 5th equation is 750 and T1R 5 minus 1, which is 750 T1 R to the 4th. All right, we don't get to solve these the same way we do in arithmetic because we don't have pluses and minuses. We don't eliminate. What has to happen when you have multiplication is you have to solve and substitute. And we're going to solve for T1. So this is going to be T1 is going to be divided by R, so 6 over R. So we're going to solve for T1, and then we're going to substitute it into the second equation. So this becomes 750 is 6 over R and R4. Well, we get to reduce the R in R4. So we have 750 is 6R3. Divide by the 6. So 750 divided by 6 is 125. In order to get rid of a cube, we cube root. We find the ratio is 5. I then get to plug that back in and see that T1 then is 6/5. I just plug it back into my R, so 6/5. Now that I know my R and T1, I use it to find my T7. So exact same thing that we did with arithmetic, just using the geometric sequence formula. And that says the 7th term is the first term times the ratio to the exponent number minus 1. So that's 6/5 to 5 to the 6th. Well, that reduces, so it's 6 times 5 to the 5th, which comes out to be 18,750. So we're going to try another one of these. Again, I'm going to ask you to go ahead and turn or pause the video so that you can try it on your own. All right, find the second term. If I tell you the third term is 24 and the fifth term is 2400. So pause the video, try it on your own, and then come back and see how you did. All right, you should have set up the two equations so that T3 is 24, T1R, and then 3 minus 1 is squared. And 2400 is T1, and then R, 5 minus 1 is to the 4th power. We're going to solve for T1, so T1 is 24 over R squared. We're then going to put that into the equation so that we get 2400 is 24 over R squared times R4. That reduces, so 2400 is 24R squared. 100 is R squared. R is going to be 10. It's actually two possible answers. It could be plus or minus 10, but because these are positives, we're going to go with the positive solution of 10. So then T1 is 24 over 10 squared, which is 24 over 100, which is 6/25. We're now going to find the second term. Since we know the first term, we know our ratio, and we know we want the second term minus 1, which is 1. So we get 60 over 25, which is 12/5. All right, example number 5. We're going to find the geometric mean. Now, arithmetic mean and geometric mean are different. Arithmetic mean is what you've always been doing. Geometric mean is a little bit different, however, not any more difficult, just different. You've never seen it before, but once you see it, you'll be okay. All right, so there's the two numbers, -2 and -18. What you do is you take the square root of the two numbers multiplied. That's the geometric mean. That's it. Instead of arithmetic, add the two numbers, divide by 2. Geometric, multiply the numbers and square root them. That's your geometric mean. Make sure if it's a non-perfect that you are simplifying the radical. For example, if it was 2 and 4, you would get 8. So make sure that you simplify that. You always want to have simplified radicals. Okay. Last one. Example 6 here. Part A, we're going to find and insert two numbers between 1/2 and 1/54. Then we'll do part B. So we have 1/2. We're going to put two numbers in between them. And then we're going to come up with 1/54. So just like yesterday when we did arithmetic, we have to use the equation. We're going to do the same with geometric. We know the last term, t sub n, which happens to be t4. We know the first term. The ratio is what we're trying to find, but we know the 1/54 is the fourth term, so 4 minus 1. So I'm going to multiply by 2, so 2 times 1/54 is 1/27. I'm going to cube root both sides, so I get 1/3. So that means multiply by 1/3. I get 1/6. I get 1/18. And if I multiply by a third again, I better get 1/54. And I do. For part B, this time we're going to insert 3 of them between 5 and 80. So 5 and then 80. So this is our T1, this is our T5. 80 is 5R and then 5 minus 1. So divide by 5. And then we get to the 4th power. Take the 4th root of that, we get 2, actually plus minus, but again we're going to stick with the positives here. So multiply by 2, multiply by 2, multiply by 2, and if I multiplied by 2 more, I would get 80 as well. So that is geometric mean, or inserting 2 and 3 numbers between it. We've had geometric mean and then using the geometric sequence formula. And then you'll have a quest coming up